Hey, what's up, you guys? Guys, I hope you're doing well. Welcome to another episode on this channel. So, this time around, we're going to be discussing, and in fact, we're going to be doing revision, right? As per ATP, we're going to be doing revision of the sine, cosine, and today's date is the 23rd of January 2024. That's today's date, and what we're going to be discussing is cosine, sine, and area rule. Okay. I don't know which one I'm going to start with, but if I was teaching live, I was going to ask you guys, but unfortunately I don't have that option to ask you. But what I'm going to do is I'm going to pick the one that I like, and that is area rule. And the reason why I'm going to start with area rule is because if you can prove area rule, you can prove cosine rule. But you see, you can prove sine rule, so you can use area rule to prove that. Okay, but cosine is kind of independent. Okay, so yeah, you need to deal with cosine in isolation. All right, so let's start with area rule. So let's suppose that you're given a triangle like this. So this topic is exactly the same in grade 11. The difference is that now in grade 12 you guys are going to be covering what we call 3D problems, three-dimensional problems, as opposed to just two-dimensional ones. So A, B, C. So you guys know this side is going to be little c, this side is going to be little b, and this side is going to be little a. So these are the type of triangles that we normally deal with, and we're just going to use normal area formula. Okay. So area of any triangle is given by half times the base multiplied by height, but the height needs to be the perpendicular height. In other words, this height here needs to be perpendicular to what we call the base. Okay, so the base the B represents our base, which is A in this case. It's not the B, so meaning that we need to rephrase. So area is equals 1/2 times A, which is the base, do you understand, and times the perpendicular height. The perpendicular height, very, very important. You need to understand the meaning of the parameters that we have over here, that the A is actually the base and the height is the perpendicular height. So let's construct the perpendicular height. So this will refer to as our perpendicular height. Okay, so now that we've got the perpendicular height, we've got our area basically, but now we need to generalize. In other words, this needs to apply for any triangle, because sometimes you find that you do have the sides and some angles, but you don't necessarily have the perpendicular height, which then becomes very difficult for you to actually find what we call the area of the triangle. So that's why we're going to sort of like replace the height with something else, and you guys are going to see how. So the height, perpendicular height, when divided by B, which is the hypotenuse of this triangle over here. Can you guys see that the perpendicular height kind of splits the triangle ABC into triangle 1 and triangle 2. So if you check in triangle 1, this ratio here represents a certain trig ratio. This is the opposite side and this is the hypotenuse, and according to Socrates, what trig ratio is that? I hope you said sine of the angle C. Okay, so now let's make the perpendicular height the subject of the formula. So this implies that our perpendicular height is equal to what? B sine C. Alright, now we go back to our original formula for area, and then we substitute the perpendicular height. So area is equal to what? Area is equal to 1 over 2 the base, which is A, times the perpendicular height, and perpendicular height is what? B sine of C. So now, meaning that our area is given by 1 over 2A times the B and the sine of C. Alright, so just to generalize, you have to say half, right, and then multiply the two adjacent sides. Okay, half, multiply the two adjacent sides, and then multiply by the included angle, which is C in this case. So in other words, if our angle of reference was B, then we'd say half A times C and then sine of the angle C. Do you understand? If the angle of reference was B, then we'd multiply the adjacent side relative to B, which is B times the C, right? The B. So let me start over because I can see that you guys weren't seeing the diagram. So what I'm saying is, you have to check what angle are we looking at. So we've got two adjacent sides. So the reason why we've got area is equals to 1 over 2 AB sine C, because I want you guys to notice the pattern. So it's you first and foremost you have to say 1 over 2. That's okay. 1 over 2. Then the adjacent side, A and B. Adjacent simply means that they're meeting at the same vertex. So this is the vertex. So A times B, so 1 over 2, product of the adjacent side A and B, and then multiply by the sine of the angle located at the vertex where the two sides meet. Okay, so now let's suppose that we're shifting from vertex C, we're going to vertex B now. Then our area would be given by, we always have the 1 over 2. So by B, what are the adjacent sides? Which two sides are meeting at B? That's A and C. So A, C, and then the sine of the included angle. What is the angle by where the two sides are meeting? That's B. So if we shift from vertex B to vertex A, then we'd say, okay, the area is given by 1 over 2. Okay, 1 over 2 times, we need to know, okay, which two sides are actually meeting at vertex A, and that's B and C. So B, C, the sine of the angle where the two sides are meeting, and that's just A. Then you've got your area. I mean, all these expressions have to give you exactly the same answer. Okay, yes, if you're doing the right thing. Okay, so that's how you prove your area rule. But remember, I said you can use area rule to do what? To prove sine rule. So we're going to take the very same expressions that we have over there. So this we'll call it A1, This is what we call A2, this will call A3. And remember what I said, all the areas need to be equal. So A2 must be equal to A1 must be equal to A2, right? A1 must be equal to A2 and must be equal to A3. Okay, so meaning that 1 over 2, I'm just going to copy down whatever that's there, right? 1 over 2 AB sin C must be equal to 1 over 2 AC sin B, also equal to 1 over 2 BC sin A. And we can cancel out everything that is common. You can see that 1 over 2 is common throughout. Yeah, and we can deal with 2 pairs at a time. Right, in other words, we can just focus on this right for now and simplify that. So you'll see that there's 1 over 2 here, there's 1 over 2 here, also there's A here, there's A there. So when we cancel things out, we're just going to be left with B sin C is equal to C sin B. You understand? So we divide the left hand side by B C, also the right hand side by BC. Just the product of the coefficients. Then you'll see that the B and the B, they cancel. So sine of C over C is equal to sine of B over B. And then we can do the same thing on the other side. Right? We say, okay, we can see that 1 over 2 is common. 1 over 2, 1 over 2. Okay? And there's what? There's C here. There's also C over there. So 1 over 2 and the C, they cancel out. So we're just going to be left with A sin B, which is equal to what? B sin A. Right? And then, remember, we've got the coefficients are A, the constants are A and B. So we're just going to divide by A and B. A and B. So the A cancels that A over there, so we're just left with sine of B over B. That's equal to what? The sine of what? A over A, because this B cancels that B. That A cancels that A. So that's why we have this. But you can see that both sine C over C and sine A over A are equal to sine B over B. Right? So meaning that these are all equal. Do you understand? So we can simply just put our sine C over C right there. Okay? Sine C over C is equal to sine B over B, sine A over A. I mean, you can flip it around so that the order is, so that the order starts to make sense, because I can see the order is kind of reversed. So normally we start with A over little a, B over little b, so on and so forth. So that's how you prove cosine rule, ladies and gentlemen. I think we'll try proving these rules one more time using a slightly different triangle, because this is, you'll see, I mean, there's these triangles are not the same, and even how you're going to prove it's not going to be the same. This is just the first type of triangle. So I'd say this is like a triangle with acute angles. There's triangles like this, whereby there's an obtuse angle like this. Now, how you prove in that type of situation, right? This type of situation, it's kind of different, you guys. So hopefully I'm not gonna forget, just to go through that type of proof. Okay. All right. Let's quickly prove cosine rule, right? So with cosine rule, this is the one that's kind of tricky, to be honest with you guys. So let's have a triangle like that, and then we'll have our A, B, C. So this is going to be little b, little c, and then little a, and then we're going to construct a perpendicular height. So we're just going to call it h, but you need to understand that it's the perpendicular height. So now what's going to happen is that we're going to say if this is x, this is going to be b minus x. So this is just the length from here to there, and the x is just from here to there. Do you understand? And then the whole thing there, that's your b. All right. And how did you find the b minus x? We said, okay, if the length from here to there is that question mark over there, we know for sure that b is then going to be equal to the question mark plus the x. Now if we make the question mark the subject of the formula, you will see that question mark is now equal to b minus x. So that's where the b minus x is coming from. So we are going to use Pythagoras twice. Okay, we are going to use Pythagoras twice, in triangle 1 and in triangle 2. Okay, Pythagoras twice. It needs to be in the back of your mind that we're using Pythagoras twice, and we're going to solve simultaneously. So now we're going to say, okay, a squared. So in triangle 1, a squared is the hypotenuse, and it's equal to the sum of the squares of the other side. So that's h squared, this side, and we know that this side is now b minus x. So plus b minus x squared. That's your Pythagoras, isn't it? Then we break this down. So h squared plus b squared minus 2bx plus x squared. Okay, that's what we have. Then we'll refer to this as equation 1. Then we go to triangle 2. Triangle 2, the hypotenuse is c, so c squared is equal to h squared plus x squared. This is still Pythagoras, right? And it's our equation 2. So we can say, okay, equation 1 minus equation 2. We're now solving simultaneously. So this is our equation 1. So equation 1 minus equation 2, just going to say a squared minus c squared. That's on the left. On the right, a squared minus a squared, they fall off. X squared minus x squared, they also fall off. So we just left with what? B squared minus 2bx. Okay? So a squared, the subject of the formula, we've got b squared plus c squared minus 2bx. Our task now is to get rid of the x. We go to the triangle which has got x. Alright, and that's triangle 2. So we're going to say, you can see that x over c is the cosine of the angle A. Alright, x over c, which is adjacent of hypotenuse, that is the cosine of A. So x over c is equal to the cosine of A. Therefore, x is equals to little c cosine of what? A. Right, x over c is equal to the cosine of A. Therefore, x becomes c cosine of A. So we go back to this, right? We substitute the expression for x. Alright, can you see that x is over there? So a squared is going to be equal to b squared plus c squared minus 2b, and then in place of x we'll substitute c cosine of A. This becomes what? B squared plus c squared minus 2bc cosine of a. Alright, so a squared is equal to that. So you also need to do this. You need to understand the pattern. Alright, because if a is the subject of the formula, a squared, then on the other side of the equation we're going to say b squared plus c squared. Then we subtract 2 times b and c. Then the cosine of the angle which is opposite a. The angle which is opposite a, that's the one. Okay? But now if our c is the side of the formula, for instance c squared is the side of the formula, fine. On the other side of the equation we're going to have the remaining sides, the squares of the remaining sides. So if we've got c squared out already, then we're going to have a squared plus b squared, right? And then we subtract 2 times a and b, a and b, a and b. Therefore the cosine of the uppercase c, right, the angle which is opposite little c, and that is uppercase c, cosine of uppercase c. So if your b is the side of the formula, then you'd have b squared. What's the remaining sides? B is out, we're left with what? A and c. So a squared plus c squared minus 2 a and c, the cosine of uppercase b, uppercase b. So uppercase b there. So you can play around with the expressions, you know. It's not that complicated, you know. Once you rewind this enough times, then it's going to stick in your head. And ladies and gentlemen, we've come to the end of the lesson. I hope you enjoyed it. Don't forget to like, subscribe and share with people that might be interested. Peace out.